Okay, we are on example 6.5. This one wasn't actually in the PowerPoint, but I liked it, so I included an extra slide here. So I've brought up the book on the left here so we can at least see the question. All right, so this is saying that Carol pushes a 25 kilogram wood box across her wood floor at a steady speed of 2 meters per second and wants to know how much force first that she exerts on the box. Okay, so let's think about this for a minute. She's pushing on this box. You know, my pictures are so good. All right, so she's applying a force in the X direction. We know that if it's on the ground, which it says is on the wood floor, that it has weight that's pulling down, but it also has the same amount of normal force that's pushing up. There is also friction involved here because it's a wood box on a wood floor. So the friction, of course, is going... Yes, I'm still here. Sorry. The friction is going towards the left. Now, here's the thing. Is the friction kinetic or is it static? Well, it says that she's pushing the box across the floor, so at a steady speed, so it's moving. Okay, so if it was not moving, then we would be saying static, but since it is moving, then we're going to say that it is kinetic. All right, so we have our forces in the X direction. We have the force that she is pushing the box minus the kinetic friction, and it's equal to 0. We're still in equilibrium mode. And then the force in the Y direction, we have our normal force minus gravitational force is equal to 0. Now, in order to figure out what the force is that she is pushing, we can move that kinetic friction over like that. And if you look at your equations for kinetic friction, it is that coefficient for kinetic friction times normal, which is the kinetic coefficient times mass times gravity. Okay, so now we have to just look back and figure out what the kinetic friction coefficient is. Hold on a second. Izzy, stop it. Sorry, I have a puppy and she's playing with her toy. Okay, so we have wood on wood, and I'm looking at the static coefficient and the kinetic coefficient. So for the kinetic coefficient, it's 0.2. Oh gosh, she's back at it. So we've got 0.2 times the mass of the box, which is 25 kilograms, times gravity. And then once you multiply that out, you should get 49 newtons. And that is the amount of force that she's having to push to overcome that kinetic friction. Okay, now, as far as the next question, it says, if she stops pushing, how far will the box slide before it comes to rest? Okay, so in this now, is there any kind of acceleration that is happening as far as, or even speed as far as in the Y direction? No. So if we look at the X direction still, and we take Newton's second law, that force is equal to mass times acceleration. Now, why in the world am I going to involve that when I'm actually trying to figure out how far? Well, if you find acceleration, then you can plug into one of those kinematics equations, right? So we need to find the acceleration in this case. All right. So we've got the that force is equal to mass times acceleration. And that is equal to our negative frictional kinetic friction. Now, why is it negative? Because if you go back up here in this equation at the top, it's negative, okay? It's still minus. So now we're going to solve for the acceleration. Okay, so if we take this like that, then we can solve for that acceleration. Now we've actually already figured out that this is 49 newtons. So if we take that 49 newtons and we divide that by our 25 here, so we've got negative 49 newtons, okay, divided by our 25 kilograms, and then we should get negative 1.96 meters per second squared. It's not gonna let me put that. Sorry. And why is it negative? Well, think about it. As soon as she stops pushing it, is it just gonna stop? Well, probably not. Like, and it all depends on, you know, the box's size and things like that. But as soon as she stops pushing it, it's going to take a little bit to slow down. Okay, so the acceleration, or the deceleration, I guess I should say, since it's slowing down, is negative 1.96 meters per second squared. Now, it's wanting us to find how far. Well, are we given time in this problem here? No, so that's going to eliminate a kinematic equation that has time. We are given velocity, and is it considered to be the initial velocity or the final velocity? Well, she's pushing it at 2 meters per second, and then let's go, and then it's going to come to a stop. So the 2 meters per second is actually the initial position, or sorry, the initial speed. And then the final speed then would be 0 meters per second. So if you look through your kinematics equations, kind of flip back over to that slide where we wrote them, you'll see this one. Okay, this has both of the velocities involved. It's got acceleration and it's got x, which is going to tell us how far it's going to go. So we've got to solve for x. Okay, so that means that we have x is equal to our final minus the initial divided by 2 times acceleration. Well, our final, I'm running out of room here. Let me make this a little bit bigger. All right, so our final velocity is 0, and that's squared, minus our initial velocity, which is 2, squared, divided by 2 times negative 1.96. Okay, and I think I'm going to, I was going to try to add a note on here, but I don't know how. Sorry. I'm still trying to figure all this out. Nope, that doesn't work either. Okay, so anyway, if you solve for this, I know this is going to look really sloppy here. I'm going to put my answer right there. If you solve for that, you should get 1 meter. Okay, that's supposed to be a 1. All right, so, you know, we just kind of have to think through the problem. It did not actually say kinetic friction, but you have to think, okay, it's moving, so I got to use the kinetic friction coefficient, and also think about, you know, which way is the box going in. Well, it's going in the x direction, so you're going to need to use your force in the x direction in order to solve. Did you have to, now it did ask in the question like what the force was that she was pushing, so that is, you know, that is this 49. But if it wouldn't have asked that, if it would have just asked how far would you have necessarily had to have done this step where you find the force? No, not necessarily. So just kind of keep in mind that if I would have I'm gonna bring up another thing really quick so I can show you what in the world I'm talking about right now. I need more space to write. Okay. All right. So the thing that I'm trying to say is that if we had mass times acceleration is equal to negative kinetic friction, and we didn't know that the kinetic friction itself was equal to 49 newtons, we know that kinetic friction is our coefficient times normal, which normal is the same thing as mass times gravity, because the force of gravity and normal is equal to each other. So we could say it like this. And if we were solving for acceleration, do we really need the mass that was involved? No. So there is a chance in your homework or in your quiz or test questions that you'll have coming up that might not have the mass. And so that might really confuse you because we did this problem where we did involve the mass. But I'm showing you over here on the right that, in fact, that mass could, cancel out. And all you would need in that case would be whatever that kinetic coefficient is and the gravity. Okay, I'm going to stop the video here and start another one.